Morning. Today we'll be seeing the third type of hydrocarbon, that is alkynes. Alkyne in previous classes. In previous classes we have seen alkanes, alkenes. So today we'll be studying the preparation properties and importance of this third class of compound, that is alkynes. So alkynes are hydrocarbons which contain triple bond, carbon-carbon triple bond. We know that single bond alkanes, double bond alkenes, and triple bond, that is alkynes. The general formula, if you see, it is CnH2n minus 2. For alkanes, it was CnH2n plus 2. For alkenes, it was CnH2n. Now it is CnH2n minus 2. That means 2 less than the double. If 3 is the number of carbon, we will have 4, C4, C3H4, that is propyne. Here, two elements of unsaturation for each triple bond. Some reactions of alkene, they undergo similar reaction as that of alkene and some other compounds. How to find out how to name the compound? We know that in IUPAC nomenclature, if there is a single bond between carbon atoms, we were using ANE as suffix to the word root, and if it is having double bond, we are naming as ENE as a suffix. Now we will write down YNE, that means carbon-carbon having triple bond. Number the chain starting from the end closest to the triple bond, and these are the some rules which we have learned. Let us see this. 1, 2, 3. Here it is after first carbon, so it is 3 carbons are there, prop, and there is a triple bond, so we are writing propyne. Here you see the 1, 2, 3, 4, and this one 5. So 5, we have a group that is bromo, 5 bromo, and as triple bond is on after the second carbon, it is pentyne, 5 bromo. Like this, it is 2, 6 dimethyl, 3 heptyne, because the triple bond is after third carbon. These are some examples where you can name the compound. See the triple bond, it is after the first carbon. But if you see, you can take into consideration the double bond also. So triple bond is nearer here. Here it is double bond is nearer here. So it is 4 methyl, 1 hexene, 5 wine. It is double bond also. Triple bond, double bond, both we are naming. Here there is a triple bond and OH group. Here it is after. So a functional group we have to give importance. Functional group is after second carbon. So 2-ol, 4 hexyl. So you can find and see the textbook and write down more examples and naming the compounds. Common names we give. This is CH, triple bond CH is acetylene common name. It is methyl acetylene. It is 2 propyne. It is propyne, but actually here we are naming as methyl acetylene. Acetylene is C2H2. Isobutyl, isopropyl acetylene. This is acetylene. Here it is isobutyl, isopropyl acetylene. We can name in this way also, but IUPAC name was that which we have seen. When you come to their physical properties, they are non-polar, like alkane, alkene, and other organic compounds. They are non-polar, insoluble in water, soluble in organic compounds. The boiling points are low and increase with the size of the carbon chain, similar to alkanes and alkenes. They are less dense than water, that means density is less anyhow. Up to 4 carbon, they are gases at room temperature. You know, acetylene is a very important gas. Acetylene. Acetylene is very important gas used in welding torches. When you go for gas welding, there acetylene is used. In pure oxygen, temperature of the flame reaches to 2800 degrees centigrade. Imagine how high. It would violently decompose to its element, but the cylinder on the torch contains crushed fire brick wet with acetone to moderate it. That means it is kept in safety. Next, if you see some other things, how acetylene is prepared. You know, commercially, acetylene is prepared from calcium carbide. Coke is heated with lime, and we get calcium carbide, and that calcium carbide, when it is hydrolyzed, what we are doing is we are getting acetylene, and calcium hydroxide is applied. This reaction is used to produce light. Miner's lamp. You see, in coal mines, people carry a miner's lamp. There they put some calcium carbide and put water, and they just put flame. That flame burns and they get light. That is miner's lamp. So this is the industrial preparation of acetylene. Acetylene is prepared by the hydrolysis of calcium carbide. CaC2 plus 2H2O gives rise to CH, triple bond CH plus CaOH twice. Try to write down this equation and balance it. If you see the structure of double bond, there will be sp hybridization. Sp means two p orbitals will be unhybrid. They form pi bonds. Two pi bonds are formed, and these hybrid orbitals sp overlap. It forms a single bond. The two pi bonds are unhybridized p orbitals at 90 degrees, which bend in cylindrical form. You see here. This is the bond which we are getting through sp overlapping. That is represented by a line here. And these two, they form upper side and lower side. With violet and blue it is shown. Py overlap, pz overlap. So two unhybrid p orbitals, they are forming pi bonds, and the hybrid orbitals, that is sp orbital, they are forming this single bonds. So you can see further structures also. Next we want to see then the bond lengths. We know single bond, the bond length is 1.54. Is it not here? If you compare the bond lengths, single bond it is 1.54, double bond it is 1.33, and triple bond it is 1.20. Bond length is smaller, and bond angle is 180 because shape is linear. Three bonding orbitals are shorter the length. That means more stable here. And because of the more stability, triple bond terminal alkynes, they are acidic in nature because they can give up hydrogen ion easily. Acetylene gives acetylide ion. Acetylide ion, that means when it reacts with NH2, one hydrogen is released, and substances which release or which can donate a proton, they are acids. More S character, so pair of electron in anion is held more closely to the nucleus, less charge separation, so they are more stable. Here an acidity table is given. Alkane, sp3 hybridization, S character is 25%. Because you see sp3 hybridization, 3/4 p character, 1/4 S character. When S character is more, pK value is 50. In double bond, that is alkenes, we had sp2 hybridization, 2/3 p character, 1/3 S character, 33%. So 44 is the pK. But if you see acetylene, triple bond, sp hybridization, half S character, half p character, 50% S, 50% p, then we say pK is 25, that means more stronger acid than alkenes and alkanes. So alkenes are acids stronger than alkanes, and because of the S character of the bond, the hydrogen ion can be easily given out, hence they exhibit that compound. H plus, this is the evidence of acidity. You are asked in a question, explain the acidity of alkenes. Hydrogen can be removed from terminal alkyne by sodium amide. Here this is the propyne. When it is reacting with soda amide, the terminal is given out. So this shows the acidic character. Then alkynes can be prepared from acetylides. This is acetylite salt. When it reacts with ethyl bromide, you get this compound, that means pentyne, 2-pentyne plus. So this is another method of preparation, not industrial. So when acetylide ions react with any alkyl halides, you get alkynes are obtained. There is another method, removal of two molecules of hydrogen. Two molecules of hydrogen from HX. Two molecules of HX from a vicinal or geminal dihalide produce alkyne. This is from vicinal or geminal dihalides. Dihalides means compounds having two halogen groups that called dihalides, and if two HX compounds are released, removal of one HX causes the formation of one pi bond. If we are removing two HX, we get two pi bonds. So here first step is easy. It forms vinyl dihalide. Second step, removal HX from vinyl halide requires strong base. How it is, we'll see this thing. You see here, this is one compound, 1, 2, 3, 4, 5. 2,3-dibromo pentane. When it is heated with COH, what happened here? First HBr is removed. HBr is removed. Here HBr is removed from this third carbon following Markovnikov's rule, and here also another. So we get a triple bond. So from, if you write hydrogen down, here also down, we get the removal of this, and we get, following Markovnikov's rule only, we get this pentyne, 2-pentyne. Alcoholic KOH at 200 degrees centigrade, that internal alkyne is obtained. The first method we have seen dehydrohalogenation, that is the second method. Industrial method you have seen from calcium carbide. So how triple bond migrates out there? To see the reactivity, we have to see all this, not necessary. So we have seen this. That means in this class, we were seeing alkynes. Alkynes are hydrocarbons with triple bond. They have the general formula CnH2n-2. They have two pi bonds, and they undergo similar addition reactions like alkenes and oxidation reactions like alkenes. So similar reactions are obtained. In the next class, we will see something, properties of this compound. So for this is the end of our class now, that is alkenes. Thank you.